This F-106 was designed in the mid-1950s for supersonic flight. NASA's Langley Research Center originally used the aircraft to study lightning by flying it directly into thunderstorms. Engineers are now using the plane for its highly swept wing to explore a design that incorporates a leading-edge flap, an 18-inch wide panel that runs the length of the wing and points downward. Wind tunnel tests with F-106 models indicate that installing the flap can increase the plane's performance by more than 20%.
265 feet.
When air passes over the wings of a plane, small tornado-like currents called vortices are generated. Again, look at the wingtip of the space shuttle as it lands.
Touchdown.
Vortices normally form along the entire wing and are important to aircraft because they generate lift. Looking at a cross-section of the F-106 wing illustrates how lift occurs. By adding a vortex flap, air is channeled both upward and forward. According to program manager Ron Smith, no wings have ever been designed to make use of this vortex.
But we're controlling that vortex, that tornado, by putting it on the leading edge, where we form a suction which pulls the airplane along.
Phil Brown is chief test pilot for the F-106 program. He finds the plane much more responsive with the flap when doing maneuvers. This wing design may someday translate into better handling qualities for fighter aircraft, as well as improvements for high-speed transports.
Particularly in the approach and landing regime, where it will reduce drag and therefore require less thrust, and therefore produce less noise because the engines will be at lower power settings.
Aerodynamic research for airplane wings is also the goal of another research team at NASA Langley. Using new construction techniques, planes fly through the air easier because they are built with smoother, more aerodynamic surfaces. As a result, planes burn less fuel, fly quieter, higher, and at faster speeds. In an effort to better understand the dynamics behind smooth airflow, researchers coat this ultra-smooth, highly instrumented Learjet wing with an oily liquid crystal preparation. Once airborne, pilots target a variety of altitudes and maneuvers designated by aerospace engineer Cindy Lee, who sits in the back making real-time analysis of flow fields over the wing. Cindy can also tell by looking at color shifts in the liquid crystal whether the airflow is smooth or turbulent. She is piecing together a series of calibrated measurements that may someday help aircraft manufacturers design more aerodynamic wings. NASA's aeronautical research, fine-tuning the latest innovations to create better airplane wings.